There is a circle passed through the point -1, 3, and also there is a center 2, 7. To be honest, this is the easiest type of equation of circle. To handle this, you should draw properly that they pass through -1, 3, so maybe approximate here. And then the center is 2, 7. So 2, 7 may be somewhere here. This is the center and it forms the circle which passed through this point, so the circle may be approximately like this. And the key point is to form this circle. There is a general point xy. The general point, any point xy here, the distance between the general point to the center should equal to the fixed radius. So in order to write down the equation of C, we should get the fixed radius by two given points first. The radius of circle is equal to the distance between these 2 points, which is delta x squared plus delta y squared, and then take square root, is from Pythagoras theorem. Delta x squared, the difference between 2 and -1, so we just simply write 2 minus -1 whole thing squared. And then the height difference is 7 and 3 difference, that means 7 minus 3 squared. Therefore, it's square root 3 squared plus 4 squared, then we get 5. So the radius here is 5. For the equation of C, the criteria is any point, the distance between any point to the center is fixed to be 5 here. So the equation is like this: distance between xy to the center 2, 7. We apply the distance formula once again. Delta x difference, x minus 2 squared, plus delta y difference, y minus 7 squared. It should equal to 5 squared, that means the radius squared. We write standard format, then we just need to express 5 squared to be 25. That's already the answer of part A. It's not necessary for you to expand it and then give the answer in general form. And then in part B1, they say that there is a straight line x plus y is minus 11 equal to 0. My habit is change the format to slope-intercept form. That means y equal to something. It's -1 time of x and then plus 11. Then I can quickly draw this line, which is going downward 45 degrees with the y-intercept 11. So this is the equation y equal to -x plus 11. Now we are going to prove that this straight line cut this circle at 2 different points. To do so, we consider the point of intersection. At this point, it fulfills the circle equation. At the same time, it fulfills the straight line equation. In short, that means it is a simultaneous equation. And you better write that down. This is at point of intersection. And our mission is to not find out the exact position of the point of intersection. We just need to know how many intercept points. So we just need to solve this simultaneous equation to give quadratic equation. Then we focus on how many real roots are there. If we substitute inside x minus 2 squared and then plus y, we place it by our target. Y can be replaced by -x plus 11. So to handle this, we have x minus 2 squared and then plus -x plus 4 squared is equal to 25. And then we expand it, x squared minus 4x plus 4. What below is x squared minus 8x and then plus 16 is equal to 25. If you start from another row, don't forget that this is not the first term, so you must write down the plus sign here. And then we have 2x squared minus 12x plus 20 equal to 25. So 2x squared minus 12x minus 5 equal to 0. We use the standard format to write down the quadratic equations. our concern is how many real roots here, so you don't need to solve it by using your calculator. You just need to consider the indicator. Delta is equal to b squared minus 4ac. b is negative 12, a is 2, c is negative 5. It's give you 1, a is 4, and the key point is this is larger than 0. It is positive. So we can draw the conclusion. Since delta is larger than 0, therefore there are two real roots for the simultaneous equation, or equivalence. That means there are two distinct points of intersection. In part B2, L cuts C at point P and Q, which means that it's cut at point P and Q. Point P may be here, point Q is here, or swap the position. It's not important. What we care is about the midpoint of PQ. That means the middle point here. But how can you find out the midpoint here? It's not necessary to know the exact position of P and Q. It's because P, one of the answer solution, the roots may be called x1, and then another root we may call x2. What we concern is the average between these two. That means the x coordinate of midpoint is x1 plus x2 divided by 2. Based on what we know here, these two roots are the roots of this quadratic equation. Even though it's more trouble to find out x1 and x2 respectively, but we can get the sum of these two roots by using the coefficient here very quickly. So that's our strategy to get the sum of roots of this quadratic equation. That means at x1 plus x2, and then we just divide by 2, we get the x coordinate of the midpoint. Part B2. Let P be x1, y1, and Q is called x2, y2. We know that x1 plus x2 is equal to the sum of roots negative b divided by a, negative something divided by something. B is negative 12 while a is 2. Therefore we get 6. That means x1 plus x2 sum of roots and an average divided by 2 will give you 3. Therefore we can draw the conclusion. X coordinate of midpoint is 3, and is also lie on this straight line. So when x is equal to 3, y is equal to negative 3 plus 11. That means positive 8. Therefore, we have all coordinates of the midpoint. The coordinates of the midpoint is 3, 8. Of course, because you have the full information about the equation of circle and equation of straight line, it's also easy for you to get the exact value of x1 and x2. But don't forget that in private exam, maybe some of the coefficient is expressed in terms of k or some other unknown. So this kind of technique, by using the quadratic coefficients to get the sum of the roots and then to get the midpoint, is a necessary skills for your DSE exam.